application. So we're going to talk about some word problems that would actually involve solving literal equations, and these are volume types of problems. Annie has a cylindrical container, so it's in the shape of a cylinder, but she does not know its radius or height. She does know that the radius and the height are the same. The volume of the container is 512 pi inches cubed. Now, volume is a cubic measurement. Find the radius of Annie's container. So, a cylinder. The volume formula for a cylinder is pi r squared h. So pi times the radius squared times the height, because we have a cylinder. The radius and the height are the same. And I don't know which one, I don't have a value for either one, but I do know that they are the same. The volume of the container is 512 pi. So instead of V, I can put 512 pi. So I just simply made a substitution for the volume. I want to find the radius. Well, since the radius and the height are the same, I can take this h out, and instead I can put an r there. So I'll have r squared and another r, and I can carry this down. So r squared times r gives me r to the third power. Remember, there's an invisible 1 on this. Like bases, keep the base, add the exponents. I want to solve for r. All right. So I'm going to need to divide by pi on both sides, because it was r to the third times pi. So that will give me 1 here. 512 pi over pi. Those pi's will also cancel. So on the left side, I'm left with 512, and it's equal to r to the third power. Just as in the previous example, if you have to the second power, the opposite is the square root. If you have to the third power, the opposite is the cube root. So I'm going to take the cube root of r to the third, and I'm going to do the same thing on the left side, the cube root of 512. So let me get my calculator. The cube root, if you press 3, math, 5, and then type in 512 and press enter, you should get 8. Now we need to include units on this because it's a word problem and they were given to us. So it says inches. The radius is equal to 8 inches for this container. So it would look like a cylinder. Let's see, here's the bottom. And the radius is halfway across the center of the circle. So this part right here would be 8 inches. If the radius is equal to the height, then we also know that this distance is 8 inches as well. Example number 5. A cone with a radius of 6 centimeters and a height of 12 centimeters is filled with liquid. Find the maximum height of a cylinder with a 4 centimeter radius that will hold the same amount of liquid. So in the previous example, I told you that the volume of a cylinder is pi r squared times the height. I'm sorry. Okay, yeah, pi r squared times the height. So in this one we have a cylinder and we have a cone. The volume of a cone, so this one is cylinder, and the volume of a cone is 1/3 pi r squared times the height. So cylinder and cone. All right. A cone with a radius of 6 centimeters. So I'm going to plug in all of the things that I know. Here's a cone, and instead of R, I'm going to plug in 6. R is squared, so 6 will be squared. And a height of 12 centimeters. So instead of H, I'm going to plug in 12. Let's find out what this is equal to. So 6 squared is 36. 36 divided by 3 is 12, and 12 times 12 is 144 times pi. Now I'm not going to multiply by 3.14 because that's a rounded answer. I'm actually going to keep my values in terms of pi. Okay. And it's still equal to the volume. All right. Find the maximum height of a cylinder with a radius of 4 centimeters. So we're looking for, what is H? Well, the radius of this cylinder is 4 centimeters. We're not given the volume of the cylinder. And instead of R, I'm going to plug in 4. Again, R is squared, so this 4 is squared. And H is what I want to find out. Well, it says that the cone and the cylinder will have the same amount of liquid, right? If they're going to hold the same amount of liquid, that means the volumes are equal to each other. So I know that the volume of this cone has to be 144 pi. So I can substitute for volume here. 4 squared is 16. All right, and normally we'll write 16 pi, 16 times pi. We write the number in front of pi. So I just rearranged that order. All right, I want to solve for H. This is 16 times pi times H, so the opposite of multiplication is division. I'm going to divide both sides by 16 pi. Pi over pi is 1, 16 over 16 is 1, and so now I have solved for H. 144 pi divided by 16 pi. These pi's will cancel out as well, and 144 divided by 16 is 9. Again, this is a word problem, so we're going to want to include units. And let's make sure we've answered the question. Find the maximum height, so we have H, of a cylinder with a radius of 4 centimeters that will hold the same amount of liquid. So our height is going to be 9 centimeters. Okay, we have another example. Example number 6. The volume of a cylinder is 980 pi inches cubed. The height of the cylinder is 20 inches. What is the radius of the cylinder? So again, a cylinder and volume. Volume of a cylinder, here's the formula, pi r squared times the height. The volume is 980 pi inches cubed. So instead of V for volume, I'm going to plug in 980 pi. Pi is still pi. The height of the cylinder is 20 inches. So I'm not given radius. That's what I want to find out. Radius is squared in the formula, but H is 20, so I can plug in 20. Now I want to solve for R. I need to divide by 20 and pi. Divide by 20 pi. Pi over pi will cancel out, that's 1. 20 divided by 20 will cancel out, that's 1. So over here I have r squared. Because I divided by 20 pi on the right side, I have to do the same thing on the left side. Pi over pi is 1. 980 divided by 20 is 49. And I don't have r, I have r squared. So I need to undo the second power by taking the square root. Opposite of squared is square root. And I get r by itself now. The square root of 49 is 7. Now we know that the square root of 49 could also be negative 7, but in terms of real life problems, we're only going to use the principal square root, which means just the positive answer. Again, it's a word problem, so let's include units in our answer. So 7 inches is our radius. Igloos are common types of homes in the northern part of the Arctic Circle. Marcel built his igloo in the shape of a hemisphere with a diameter of 12 feet. Calculate the volume of the igloo. So this is a hemisphere. Well, I know that the formula for volume of a sphere is 4/3 pi r cubed. And a hemisphere, hemi means half, so half of that will be the volume of a hemisphere. And we can actually simplify this. 4/3 times 1/2. 4 times 1 is 4. 3 times 2 is 6. And you could even simplify it one more time, but for our problem, it's not going to make a difference until the end, so we can just simplify later. A diameter of 12 feet. Now, we don't have diameter in our formula, but we do know that the radius is equal to 1/2 of the diameter. So since the diameter is 12, half of that gives us 6. The radius is 6 feet. We can substitute 6 into our formula. 6 in place of r. And it's to the third power because r is to the third power. And we simply just crunch these numbers. So we have 4/6 times 6 to the third power, which gives us 144 times pi. So make sure you keep pi on there. Calculate the volume of the igloo. So volume is equal to 144 pi. And again, we need to include units. And this was in feet. So we can say feet cubed or cubic feet. And the last example, example number 8. Brandon knows that his truck route from Illinois to Tennessee is 430 miles. He also knows that distance is equal to rate times time. So here I wrote D equals RT, distance equals rate times time. How long will his trip take if he averages 50 miles per hour? So we're finding out how long. We're finding out what is T. The distance is 430 miles. So instead of D, I'll put 430. The rate, that's how fast he's going, is 50. So instead of R, I put 50. And T is what I want to find out. So 50 times T, the opposite would be to divide by 50. So now I'm left with T. And 430 divided by 50 is 8.6. So the time that it will take him for his route is 8.6 hours, miles per hour. So we know we're talking about hours.